Did you know that the most expensive step in making a biopharmaceutical drug isn't growing the cells? It's purifying the protein? And the real hero here is chromatography. So what exactly is chromatography? In simple terms, it's a separation technique that lets me isolate the target protein, think antibodies, from the thousands of other molecules swirling around inside a bioreactor. Without this step, medicines would never be safe or pure enough for patients. It's the difference between a miracle cure and a chemical soup. Let's break down the 3 most common types of chromatography you'll find in biopharma. First up, affinity chromatography. I like to think of this as a lock and key system. The resin inside the column is designed so the target protein sticks to it perfectly, almost like Velcro. Everything else just washes away. Then, with a little tweak, I release the pure protein. It's precise, efficient, and honestly kind of satisfying to watch in action. Next, ion exchange chromatography. Here, I'm separating proteins based on their charge. Imagine positively or negatively charged resins acting like molecular magnets, pulling in and separating out impurities. It's the ultimate game of opposites attracting, and it helps ensure only the right molecules make it through. And then there's size exclusion chromatography. Think of this as a molecular sieve. Large molecules zip through quickly, while smaller ones take their time weaving through the maze. It's perfect for removing aggregates or those pesky fine impurities that could affect the final product. Each of these steps brings me closer to a drug that's pure, potent, and most importantly, safe for patients. But here's the catch: chromatography columns and resins are seriously expensive. In fact, purification alone can eat up about 50% of the total cost of manufacturing a drug. That's why a lot of research right now is focused on making this process faster, greener, and less expensive. Continuous chromatography and membrane-based alternatives are on the horizon, promising to transform how we deliver life-saving medicines. So the next time you hear about a groundbreaking antibody therapy or a new vaccine, remember this: behind every vial is the quiet, powerful science of chromatography. It's the true heart of biopharma purification, and it's shaping the future of medicine.